Okay, we're now recording, and today is session number 4, the second part of systems of linear equations. Okay, so we're going to start with what's on the dry erase board, so you might want to zoom in on that. Okay. One of the most overwhelming parts of test taking is finding out what they're asking you to do for the problem. I'm sure y'all would all agree about that, right? When you start reading it, you're like, what do I do? Okay, so I made some notes here for you guys to write down, and you can always, I'll send you a picture of this after by email, so you don't have to write it down now. You can just look at it. I'll email you a snapshot again so you can write this down at a different time. For now, just really focus. They typically like to use G and K as a constant. So K is a famous constant. They use K 90% of the time. Sometimes they say G. They could say B, A, F, Z, any letter in the alphabet. When they say blah is a constant, and that's in quotes, what they're saying is K is a number we don't know. That's what it means when they say blank is a constant. It's a number we don't know. Anytime they say ordered pair, they just mean X comma Y or a point. Anytime you see solution to the system of equations or satisfies the system of equations, it simply means they cross or intersect. And here's an example. 2 lines, y equals mx plus b, where the slopes are different. Doesn't matter what the intercept is, but they're going to cross somewhere. If you see system has infinitely many solutions, that means they are the exact same equation. Okay, they have infinite solutions means they are the same line. So they're either the same exact equation, or they may trick you. They may have it look like this. They may have y equals 2x plus 1, and then the other equation may say 2y equals 4x plus 2. But if you simplify that equation and divide everything by 2, your brain should notice it's the same thing. They are the exact same equation. One is just amped up by a multiplying by some number. If you see system has no solution, it means they're parallel. They have the same slope, which is the m, but different y-intercepts. The b is different. So it would look like this. Y equals 3x, and this part could be anything. So the number in front of the x has to be the same. That's the m. And the b, which is the y-intercept, they have to be different. That's what that means. So we're going to go over this a lot. So don't waste time writing it down right now. Just look at it while we go over this. Okay. Let's, we're going to go to our books, for instance. And let's look at number 1. Okay, sorry, page 37. Okay, I want you to take your highlighter, take out your yellow highlighter, and this is what I want you to kind of do. Yes, mine is very sloppy and messy, but I was doing it quickly. I just want to give you an idea of what we're going to do here, okay? I want you to take your highlighter, and we're going to look at number 1, the ordered pair. So anywhere you see a term in quotes that's on our board, on the dry erase board, I want you to highlight it in yellow. So if the ordered pair, so you're going to highlight ordered pair x comma y, and highlight solution to the system of equations above. Okay, so you're highlighting. Okay, highlight ordered pair, solution to the systems of equations above. So that sounds a little overwhelming. It's a lot of words. But, okay, if you look at that and you replace it with what's on the board, what you see is if a point is where the lines cross, what is the value of y? Ordered pair So when you see ordered pair, you can think a point. And when you see solution to the system of equations above, right here, they cross. So if you read this again, you would read, if a point is where the lines cross, what is the value of y? Does everyone see that?
Mm-hmm.
Okay. Let's go to number 2. You're going to highlight any phrases I have on the board. A graph of a system of linear equations is shown above. That's totally, doesn't really matter if you read that or not. I mean, that's not that important. It's just stating, look, I have a picture of 2 lines. Okay, if the ordered pair xy, so you're going to highlight that, ordered pair xy, represents the solution to this system, so there's your solution to the system, what is the value of x minus y? So you're highlighting those because in place of this, you can say, if a point is where the lines cross, what is the value of x minus y? Okay, yeah, so for now we're just highlighting. Let's look at this one over here, number 4. We're going to highlight solutions as a system of equations shown above have, right? So we could also say, how many places do the lines cross?
One. Huh?
We're not going to answer it yet. We will in a little bit. We are going to work out most of these. Most important part is if you know how to not panic when you see all these words and know what they're asking for. So let's look at 7. Right? We highlight ordered pair and satisfy system of equations above. Right? All right, there we go. So if a point is where the lines cross, what is y? What is the value of y? I want to make sure everyone highlights those things. We're going to start recognizing these a lot easier after we do these. That's why we're doing a bunch today. Let's look at number 14. If the ordered pair satisfies a system of equations, there's your 2 things to highlight. Ordered pair satisfies a system of equations. So 14 is if a point is where the lines cross, what is xy? We're going to go over some more of these. Don't worry, we're going to go over these again. I just want to do roughly, right now we're just highlighting. 15. In the system of equations above, g is a constant. If the system has infinitely many solutions, what is the value of g? That's a lot of math terminology there. Highlight g is a constant, and highlight if the system has infinitely many solutions. So we're going to rephrase that to say, right, what do we say if it's a constant? It's just what?
We don't know what it is.
Right.
It's an unknown.
Yep. So we're gonna think when we see this, we're gonna say g is a number we don't know. If these are the exact same equations, what is g? System has infinitely many solutions. They're the exact same equation. So when you see that, you would think g is a number we don't know. If these are the exact same equation, what is g? Now, wouldn't it be much easier if I just said that on the question? That'd be way too easy, so that's why they make it complicated. Let's look at 18. 18, we're highlighting if the ordered pair satisfies system of equations above, there's 2 things to highlight. So 18 is if a point is where the lines cross, what is x plus y? We're highlighting those. Don't worry, I'm going to give you time to write in a minute. Right now we're just highlighting. 19. In the system of equations above, k is a constant. If the system has no solution, what is the value of k? Okay, So 19 is saying k is a number we don't know. These lines are parallel, have the same slope m. What is k? Okay. So now I want you to get out a sheet of blank paper and a pencil and some highlighters. We're going to get this ready, okay? So you want to keep your SAT prep book open. Okay, someone's getting breathy there in the headset. You have to scoot it back a little. Just a little. Okay, there we go. Let's see. Let's open up to the beginning, and that is page 37. Okay. We're going to rewrite number 1. And this is how we're going to rewrite it. Okay. Everywhere I replaced an easy word for a complicated phrase, I'm going to circle it somehow. Okay. So if the ordered pair, if a point, so you're going to write if a point you're going to circle in some color. Pink is fine, doesn't matter to me. I just want your brain to catalog that instead of the fancy terminology ordered pair x comma y, you're just putting a point.
Should we be writing this on the notebook or on our graph paper?
Anywhere you want. It can be on your graph paper, is fine. I just did this on white paper. You can too, but I did it on white paper so it would be easy to focus from the camera, to focus on it easier. So let me know when you're done writing this one down. And notice at the end is when they always add a question, right? They give you information like if a point is where the lines cross, or they're parallel or whatever, then they ask you for, always ask you for something else. What is the value of y? What is the value of x plus y? What is the value of xy? What they want you to do is find x and y and then do something with those two answers. Okay, that's what all of these are about. And this is a good way to really chug through the SAT and get some points. I'm going to skip most of these long word problems because those are tricky. They can be tricky. They can be subjective. And I encourage you to go through those big word problems by yourself and read through this book and read how they solve them. What I'm trying to give you is a plan of attack where you can answer a lot of these very straightforward math problems. If you know how to solve 2 equations and 2 unknowns, and you know how to interpret what they're asking, you should be able to get all of these without having to figure out how many ice cube trays they want to deliver with the ice cream truck and how many people are wearing blue shirts when they do it. You know, those strange word problems that they have. These are the ones I like. Well, I like these. Okay, so we've got number 1. Let's do number 2. Here's 2. 2 is simply, I'm not even going to rewrite the first part. The graph of a system of linear equations is shown above. That's obvious. That's Captain Obvious. If the ordered pair represents the solution to this system, what is the value of x minus y? All of that can be written this simply. If a point is where the lines cross, what is the value of x minus y? Let's rewrite number 2. Wouldn't the test be easier if they just did this? Everyone's supposed to say, yes, it'd be so much easier.
Yeah.
Yes.
Yo.
Okay. Okay. You ready for the next one?
Mm-hmm.
Number 4. How many solutions does the system of equations shown above have? How many places do the lines cross? It could be not at all. It could be 1. It could be infinite. We don't know. And we are going to go back and solve these. Don't worry. We're going to rewrite them first to catalog this in your brain. Okay, ready for number 7? Next one?
Yes.
Okay. Katya, are you there?
Yes.
Okay. Number 7. If the ordered pair satisfies the system of equations above, what is the value of y? If a point is where the lines cross, what is y? So, Katya, you tell me when you're done writing that one down. Because you're being very quiet.
Okay.
14. If the ordered pair satisfies the system of equations above, what is the value of x times y? xy. 14. If a point is where the lines cross, what is x times y? Anyone done? Let me know.
I'm done.
Okay. I'll also send you can also pause on this on the video if you want to rewatch it and you didn't get to write them all. 15. In the system of equations above, g is a constant. If the system has infinitely many solutions, what is the value of g? That's a lot of words. Here's what they're saying. G is a number we don't know. If these are the exact same equations, what is g? Okay, let's look at 18. If the ordered pair xy satisfies the system of equations above, what is the sum of the values of x plus y? 18. If a point is where the lines cross, what is x plus y? Notice the sum of x and y is another fancy way of saying x plus y. What is the sum of x and y? What is x plus y? We have one more. One more, 19. In the system of equations above, k is a constant. If the system has no solutions, what is the value of k? 19. K is a number we don't know. If these lines are parallel, same slope, which is m, what is k? Let's chime in when you're done writing these down, or at least most of them down.
Done.
I'm done.
Okay, that's 2 of you, so I'll be sure this will be on the video if you want to freeze frame it next time, or when you get the link. So, now that we have our new questions, we already did 1 and 2, so let's start with number 4. How many places do the lines cross in number 4? So, first we're going to number 4. How many places do they cross? So we have 4x minus 2y plus 3 equals 8. 3x plus 6y equals 8y minus x plus 5. Okay. And we have two equations, two unknowns, and I'm going to assign some little bit of homework, just stuff for you to do at home. I can show you how to start a problem, how to attempt the process, and how to get the answer, but the algebra behind it is your own. That's on you. So if you need more help with the algebra part of this, I'm going to give you some quotes from places and chapters in this book, the Saxon Algebra 1 3rd edition book. I'll give you some problems today for you to look through here. They have really good how-to step-by-step processes for these equations we're going to be solving. So just so you know, here for the lesson, I'm going to work them out very slowly and step by step. But on the test, you need to be able to do it much quicker, and you need to be able to skip a few steps if you can. And just know that if I, for instance, want my y to be positive, I can start off my equation and just put my y on the right, because I'll be adding 2y. These are things you learn from doing hundreds and hundreds of equations. You learn to know the fastest way to solve for y. Yes, you can leave it over here and have a negative. That's fine. As you get faster, you'll start to be able to put it on the right side. Like you may have something like 3x plus 4 equals y. You can actually just write it out. Y equals, doesn't matter which side it's on. So the y equals mx plus b. For now, we're going to keep this our standard format, because a lot of these problems are asking about slope, intercept, parallel, intersecting. The fastest way to know if they have the same slope, which means they're parallel, or if they're the same line, is to get them all in this format. Y equals mx plus b. So that's what we're going to do. Okay. So I have let's start with this one. I'm going to move this y over to this side. So I'm going to subtract 8y from both sides. Okay, I end up with, like I said, when you're on the test, you won't write all this out, but I'm doing it for the video. Minus 2y equals, I'm also going to subtract 3x from both sides. And then I will end up with 4x. I'll end up with minus 2y equals 5 minus 4x. See, that's a little bit of a shorter step. I went ahead and did 2 comps in one thing. So I at least already have this sort of going in the right direction, if that makes sense. I'm going to divide both sides by -2. So that I'm left with y equals -5/2 plus 2x. In proper format, y equals 2x minus 5/2. Okay? So this is this equation. Okay? For the top equation, I'm just going to rewrite it here. 4x minus 2y plus 3 equals 8. I'm going to subtract 4x from both sides. I'm also going to Subtract 3 from both sides. And what I'm left with is negative 2y equals negative 4x plus 5. Divide both sides by negative 2. Y equals 2x minus 5 over 2. Okay, so number 4, what do you notice about these two equations?
They're the same.
They are the exact same equation. So how many solutions do we have? System, yep, system has infinitely many solutions. Okay, so infinitely many, the answer would be D. Infinitely many. Because they're the same. Any questions on that one?
No.
Okay, you can always ask the question after. When I turn off the video, I'll take more questions at the end as well. Okay, now we're going to do number 14. So let's look at 14. Is if the ordered pair satisfies the system of equations shown above, what is the value of x times y? So 14 also says if a point is where the lines cross, what is x, y, or what is x times y? So 14, I'm going to write out the equations first of all. We have x plus y equals negative 6, y minus 4x equals 4. Okay. Now the question is, what is xy? So what we have to do, number 1, is what? We have to find x, find x and y. What is xy? Okay. And here again, the easiest thing to do is set this up y equals mx plus b. That's always a good place to start because we have two equations, two unknowns. Okay, that's a pretty common thing here. That's our theme. We always seem to have two equations, two unknowns. Let me write that down every now and then so we know what we're looking at. Two equations, two unknowns. Okay, so let's solve these out. We have y on the top one. Y equals negative x minus 6. This is the part you need to be able to write without having to work it out step by step if they're short like this. Right, I have my y, I just subtracted the x and put it over here. So it's a negative x minus 6. Same with the second one. Oh, let's watch your mouthpieces. Someone needs to move the mouthpiece a little bit farther away. We're getting breathing again here. Y equals negative x minus 6. Okay, and the bottom one, same thing. Y equals positive 4x plus 4. Okay. These are short enough that you should be able to do that in one step as you're rewriting it without having to waste time writing it out step by step. But if you have to, go ahead. There are no, you don't get docked for leaving any empty or having wrong answers, so whatever you need to do. Okay, this is where we talk about, for a little break here, now that we're doing a bunch of these types of problems, I didn't want to overwhelm you last week, but there are two ways to solve for two equations and two unknowns. One is substituting. Let's write this down. Substitute, or to add cancel. You know, add so it cancels out. Okay, these are your two. And this is what you're going to practice over the week. I'll go back and give you some of those ideas out of your two equations, two unknowns. You can substitute or add and cancel. Substitute means solve one equation for one, stick it in the other equation where you have that variable, and then plug and chug till you get an answer. Add and cancel is what we were doing last week, where you line them up like this and add them down. Okay? For the sake of bringing in a substitution, so this one you could completely just do the add cancel. You could multiply one of these by a negative, and your y's would cancel out, and you'd end up with an x, and you could solve. Okay, so yes, you can do it this way. But I do want to show you, sometimes when they give an equation that's this simple, it's actually faster to just substitute. Meaning, I would take 4x plus 4 equals negative x minus 6. I would take this y, right, from this equation, and set it equal to this y. What I'm basically doing is setting y equals y. I'm saying this y equals this y. And because they're both already solved for y, I can just put them side by side and solve. If I add x to both sides, I get 5x. And I'm also going to subtract 4 from both sides. 5x equals negative 10. Negative 6, negative 4 makes negative 10. 5x equals negative 10. Divide both sides by 5. X is negative 2. I highly suggest rewatching the video and pausing it in some of these areas. So here's our x, right? We just found our x right there. Now let's find the y. If we know x is negative 2, I'm going to take the shortest route for this one, which is, I'm just going to pick, let's see, I'll just pick this equation. Doesn't matter which one you pick. I'm going to take y equals negative x minus 6. And in the place of x, I'm going to put negative 2. Y equals, that becomes positive, so we're left with negative 4. What have I not used yet? Have I used purple? I've already used pink. It's okay. We're going to call this, there's our, what they want up here is what is x times y. So x times y is -2 times -4, which is +8. So that's the answer you would put in. Okay. Answer is 8. That's our final answer. I'm just going to yellow again just to, we're not running out of colors. I'm out of colors. Okay. That's 14. Let's do 15. I think I have 15 next on my list. Yes, 15. Let's do 15. I'm going to write this down before I read it. 4x plus 7y plus 24.
What?
15. Okay, 15. In a system of equations above, g is a constant. If the system has infinitely many solutions, what is the value of g? So 15, we're saying g is a number we don't know. If these are the exact same equations, what is g? Okay, we know they're the exact same equation. They just don't look like it, right? But they are. So the easiest way to prove they're the exact same equation is let's just get them in a simple format. Y equals mx plus b. Doesn't have to be this one, but this is what your brain knows, and we're just going to keep going with this one. Y equals mx plus b. Okay. So on the first one, we have, I'm leaving the 7y over here. I'm going to have a negative 4x plus 24. Now we divide both sides by 7. Sorry, this is a y. My handwriting is a little bit sloppy there. That's a y. Okay, 7y divided by 7. So I have y equals negative 4 over 7x plus 24 over 7. Okay, let's do the next one. And I want you to notice that we're doing number 15, okay? This is actually in the hard section. And the only reason it's in the hard section is they're assuming students will totally miss the part where it says the system has infinitely many solutions. Okay? That's where they're going to catch most of the kids. And you will know when you get to this problem, it just means they're the exact same equation. If you know that, you're ahead of the game. You can just plug and chug all these numbers and you'll be fine. Okay, 6x. Let's do the next one. The next one I have 21 over 2y equals negative 6x plus g. And now the only way to get rid of this is to multiply both sides times 2 over 21. Y equals, I'm going to write all this out. I'm not going to do this in my head for you. I'm going to leave it out. Equals negative 6 over 1 times 2 over 21x plus 2 over 21g Let's see if these align. Okay, you can either do this by hand or you do this with your calculator. Okay, you can say, you can make it a fraction if you want. You can say negative 6 over 1 times the fraction of 2 over 21 equals negative 4/7. Y equals negative 4/7 x plus 2 over 21g. This is where I want you to notice. So we have our two formats here. Notice our x variable term. See how those are identical? Because they're identical and the y's are identical, if we know, as we solved from the reading out the question, these are the same exact equation, okay? Same exact equation. So therefore we know that, sorry about that, my pen is stuck. We know that these have to be equal, correct? Right? We know those have to be equal because everything else is the same. The y is the same, negative 4/7 x is the same. We have 24/7 and 2 over 21g. So what we do is we say 24 over 7 has to equal 2 over 21g. This means we multiply both sides of the equation by 21 over 2. Those will then cancel out and we will have what g equals. I recommend just, this one you could just cross cancel. I'll show you both ways. These numbers look very easy on my eye. I see a 7 and a 21. I would make that a 1. I'd make that a 3. 2 and 24. I'd make that a 1. I'd make that a 12. I would get 36 equals g. If you want to do it with the calculator, you would have 21 over 2 times 24 over 7 equals 36. So there's your answer. G is 36. Okay. We're sort of running out of time, but I want to show you I want to at least begin 19. To me, 19 is important. Let's at least do some of 19. 19. In the system of equations above, k is a constant. If the system has no solution, what is the value of k? 19, we rewrote. K is a number we don't know. If these lines are parallel, have the same slope m, what is k? So I want to give you the way to solve 19. 19, we take our two equations, 11x minus 24y equals 8. And then we have k times x minus 36y equals 5. Okay, here again, we need to put it in this format. And what do we know because of the question? We know that the lines are parallel. Let's write that down. Lines are parallel, so that means that the m is the same. You can say same slope. Okay, so we're going to get them into y equals mx plus b. And then do what we did in the other problem, set the m's equal to each other, and because they have to be the same. So we're going to do the same similar thing we just did in the last problem. Let's see here. Okay. I'm going to go ahead and just give you how I solve those to save time. In the first one, I end up with y equals 11 over 24x minus 8 over 24. The second one, y equals k over 36x minus 5 over 36. Okay, what I wanted you to see is because we are dealing with lines that are parallel have the same slope, right? If the slopes are the same, that means these terms have to be the same. So that means 11 over 24 should equal k over 36. Do both sides times 36. And yes, you can do this both ways, but I'm going to do it with the calculator. 36 over 1 times 11 over 24 . 16.5. That's the value of the constant k. Okay. Okay, I'm going to end the video here. In the recording here.